my name is Kelsey, and in this presentation I will walk through the helicopter design experiment where factorial design was used in order to analyze and improve the flight performance of a paper helicopter. So this experiment demonstrates how design of experiments, or DOEs, can be used as structured engineering methods to evaluate multiple design variables simultaneously, and then determine which factors most strongly influence the overall performance. So the goal of this lab was to determine which design parameters produce the longest helicopter flight time. And the objective of this experiment was to apply a full factorial experimental design to analyze the effect of several helicopter design parameters on their flight time. So instead of testing one variable at a time, factorial design allows us to study multiple variables simultaneously while also identifying the interaction effects between each of them. So I think this is important because using all the combinations selected, the experiment can determine not only like which variables matter the most, but also how they interact with one another. The task of the experiment was to evaluate 4 design factors that influence the helicopter as it falls from the second story. So the first factor was the body width, which could either be 30 millimeters or 50 millimeters. And then the second factor was body length, which could be 80 millimeters or 130 millimeters. And then the third factor was the wing length at 80 millimeters and 130 millimeters. And then the fourth factor was whether or not the paperclip was installed on the helicopter, which obviously changes the weight and the center of the gravity. So each factor had 2 levels, which created a full factorial design with ultimately 16 helicopters. So for our experiment, the full 2 to the 4th factorial design was used. So with 4 factors, 2 levels for each factor, total of 16 helicopters were required in order to produce every possible combination. So each helicopter was constructed according to the design matrix. So according to our template here and the design matrix here, which produces our measurements for each of the 16 helicopters. So for each helicopter, we predetermined the order in which they would drop so that it wouldn't be sequential. So this was predetermined, so I wrote these down prior to dropping them. And so after each was dropped, we recorded results here with average time. So we did 3 runs according to the results. We can see that helicopter 2, run 2, had the highest average descent time of 5.33 seconds. And so for that helicopter, we can see that the body width was 50 millimeters, the body length was 80 millimeters, the wing length was 80 millimeters. There was no paperclip, so it didn't have that additional weight. And so obviously it was able to hang a little bit longer in the air. So overall flight change, the range for each of the flights averaged about 3.76 seconds, which just indicates a measurable performance between each helicopter design. We'll move into our kind of analysis. Sorry, bear with me. I've got a little bit of a cold, so I'm trying to power through this without making it, too boring of a video. But our main effects were body width, body length, wing length, and whether or not the paperclip was installed. So calculated those effects here using this formula. And we indicated that the factor with the largest absolute effect was the paperclip installation, indicating that it had the greatest influence on flight time. Interaction effects between the two, so that's kind of outlined here. And then we have a Pareto kind of chart of sorts that we're able to rank the factor interactions, the effects, and the absolute effects there. So, to kind of conclude, we did the Pareto analysis up here. So second largest factor was paperclip. Largest contributor was the variation interaction between body length and paperclip installation. From engineering perspective, I think helicopter performance is influenced by aerodynamic drag, center of gravity, stability, and mass distribution. So I think balancing all these physical characteristics is pretty crucial when you're trying to optimize the helicopter design. To conclude, the factorial design experiment successfully identified the most influential factors affecting the helicopter flight time. The optimal configuration used a wider body, shorter body length, shorter wings, and no paperclip. The experiment demonstrated how factorial design can efficiently evaluate multiple variables and reveal just important interactions between them. So I think it's a pretty powerful tool. And then I think the method is just widely used in engineering, so it provides just a structured and just data-driven approach to optimizing your design. So thank you for watching this presentation on my helicopter performance using factorial design.